Hello! In this video we will cover how to derive the quadratic formula. As the purpose of the quadratic formula is to determine the x-intercept values of a second-degree polynomial, we will start with our second-degree polynomial with variable coefficients in the general form and set it equal to 0. From here, our goal is to solve for x. Our first goal is to get x in a position where it exists as one term. As it stands, x currently exists as the first and second term in our equation, but we know a few tricks to solve that problem. First, we will aim to complete the square so that we can take its square root, thus getting x plus some quantity squared. To start this, we will need to simplify the complexity that the a value is now creating. Simply dividing the first two terms by a will do the trick. This gives us a times the quantity x squared plus b over ax. Notice that this hasn't changed the value of these two terms. We've divided them both by a and multiplied them both by a, essentially multiplying them both by 1. We also bring down our c and set the right side of the equation to 0. Now we can complete the square of these two terms in the parentheses. We know from the rules of completing the square that our c value should be our b value divided by 2, then squared. Our current b value is b over a, so dividing that by 2 gives us b over 2a, and squaring it gives us b squared over 4a squared. But we can't stop there for this step. We've added a value to the equation and so must also subtract it from the equation in order to not change the value. We do this by subtracting not just the value that we added inside the parentheses, but because we are subtracting it outside the parentheses, we must subtract it times the a outside the parentheses. This means that we are subtracting a times b squared over 4a squared, which we can simplify by knocking this and this out to b squared over 4a. We then bring down our c and set the other side of the equation to 0. Now that we have completed the square, we can square root it and also square it, which will change its composition but not its value. By the rules of perfect square polynomials, the square root of the terms inside the parentheses is the b value divided by 2 plus x, which means x plus b over 2a squared. We bring down our other terms and set the other side equal to 0. So now we've accomplished our goal of having x as a single term, and we can start to solve for it. It's a bit of a mess, but we can get there. The first thing we need to do to isolate x is look for any terms that are only added to the x term and subtract them from both sides. We have our b squared over 4a as well as our c. As the b squared over 4a is negative, we can add it to both sides to move it, and we could subtract the c from both sides to move it, giving us a times the quantity x plus b over 2a squared equals b squared over 4a minus c. Now we look for any multiplication that we can remove. We have our a multiplied by the parenthetical term, so we can divide both sides by a to remove it. This gives us the parenthetical term on its own on the left, and on the right we have b squared over 4a squared minus c over a. Before we jump into removing the square on the left side of our term, let's clean up the right side of our equation a little bit. To do so, we need like terms. As our 4a squared is our greatest common denominator, we multiply our c over a term by 4a over 4a. Since this is equal to 1, we have not changed the value of the term, and now we can combine them into something that is hopefully starting to look familiar. So we have our b squared minus 4ac over 4a squared. Let's remove our squaring on the left term by taking the square root of both sides. While the square root of this entire right term might look daunting, we can simplify it a bit. As it is a square root of a fraction, we can set it equal to the square root of the numerator over the square root of the denominator. As this is a perfect square, we can set that equal to its square root, which is 2a. This should be looking very familiar because we will have one last step to get to our goal. We just need to subtract our b over 2a, and now since these are like terms, we can combine them directly. So we have x equals negative b plus or minus. Pause real quick to go over why this is plus or minus. Because since we're taking the square root, the original term or the original value underneath the square root is going to be positive, but the square root of it can be positive or negative. Think about it, the square root of 4 can be negative 2 or positive 2. They both square to 4. So we have plus or minus the square root of b squared minus 4ac over our 2a. So there you have it. X equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a, or the quadratic formula. Thank you for watching. If you have any questions, leave a comment.